Hello everyone, I am Uttam Khatri, pursuing my BTech from the lovely professional university. Today we will be discussing about a very commonly used data structure, that is tree. So let's begin. Tree is a non-linear data structure which organizes data in hierarchical structure, and this is recursive definition. So what this means is, let's say, it means recursive definition means that it will repeat itself again and again. The hierarchy of tree will repeat itself again and again. So this from this. So it's an hierarchy and this will repeat itself again and again. That's why we have called this recursive definition. So tree data structure is a collection of data node which is originally in hierarchical structure recursively. So these that I have created circles, they are kind of nodes and they are repeating it themselves. So it's a kind of tree data structure. So now we will be discussing about difference between a tree and a binary tree. So a tree can have multiple, let's say this node, first ever node of a tree is called root node, or you can say parent node. And if it has multiple nodes coming out of it, these are called its children. So when a parent have more than two children, then that is called a simple tree, or we can say a simple kind of tree. And what differs binary tree from others is that it can have maximum of two children. It can have two, one, or no, like it has no, no children. So it is a part of binary tree. Here it have two nodes. Here again it have two nodes. E also have two nodes, and but I don't have any node, so it is a binary tree because it has maximum of two children. So now we will be discussing about some of the very basic definitions, or you can say things that we should know before diving into trees. So that is node. So node that we have discussed previously also in our linked list, that node is a kind of, you can say, class that stores information int, any kind of information, data, and reference to next node in linked list. But in case of tree, it has three elements. In first, it store data. In another, component, it store the information about the right children, and in left, it store information about the left children. So root, the first ever node of any binary tree is called root. So here this is root. And next children, the when a binary tree is repeating itself in successive manner, then these are called its children. So it has a root, and these are two children. And parent are, of course, kind of the nodes from which the nodes are taking out. So 17 is parent of 12 and 23. In the same way, 12 is parent of 9 and 14. But the first ever node or the first ever parent is called root. And simply these are known as, like, 17 also have subsequent nodes, but it will not be called root. It will be called just parent. And they are also children of the root node. So siblings, the nodes that have common parent, like 54 and 76 have common parent, that is 72. So these 54 and 76 are called siblings. Ancestors, of course, when we go up the tree, then they are called ancestors. 12 is ancestor of 9, 17 is ancestor of 12. In the same way, root node is ancestor of 17. So descendants simply the opposite of ancestors. So leaf node are called node that doesn't have any another node connected to them after them. Like say 67, it doesn't have any node after that. So it is called leaf node. So these are the some basic information that we should know, the basic terms we should know about trees. So now we will learn how to create any tree, how to insert elements in it, and multiple functions related to trees.
We have seen the basic terminologies related to the difference between a normal tree and an. Now we will dive into some of the operations in binary. So first operation that we usually perform is insertion. simply means inserting any node into the binary tree. So what are the things that we need to take care while insertion is, let's say we need to insert node in the binary tree. So first of all, what we will see, we will come to the root node and check whether it has left child or right. That's now in this case, the left child of root node that one is missing. Then we will simply add the two, that is one root node, to the left child of the root. And so the node tree will be like this after adding of the node. So let's say we have both left and right child. Then how we will insert? Then we will simply, let's say we have to insert 7 as a new node. Then what we will do, we will basically, we have 1, 2, 3, and 6. What we will do, we will do the deepest as we can go in our tree. So what we have 6. And what is the parent of 6? 3. So 1, we have our root node have both children, 2 and 3. Then let's say we go to 2. It has none, no neither left child nor right child. Then we will go to 3. It has 1, 6 left child but not the right child. So we will simply add the new node to its right child so that its pair get completed. So this is how we perform insertion in binary. So next we will see how we perform deletion in the binary. So deletion simply means removing the node from binary tree. So let's say we have to delete node 1 from the binary tree. That is root 1. So node 1 is deleted and replaced with the deepest node, that is 3. So whenever we have to delete any node that breaks the chain of what we call tree. Let's say one was connecting 4 and 3. So when one is removed, a kind of chain is broken. So we replace 1 with the deepest element in our tree, that is 3. So 3 will simply take the place of 1 and the new tree will be 3. And so let's say we have the new tree 1, 2, 3, and two children of 2 are 4 and 5. Delete node 5 from the binary. As we can see in this that 5 is leaf node. So there is nothing like it is balancing that we or connections are being broken as we remove this node is nothing like that. So we can just simply remove it because it is a leaf node and our node array will be like this. One, two, three, and 5 is simply deleted. So now let's say in the next question we need to node 2 is deleted in this new binary. So what we will do? We have one, two children of are 2 and 3. And there is one children of 2, that is 4. So it's just, kind of common sense. Say we delete. So what we can connect? We had 1, 2, 4, and 3. If 2 is not there, then simply we have a space in between. So we will just simply connect 1 with 4. That is deepest node. So 1 will connect to 4 and 3 is already the children of 1. So new tree will be looking like this. So that is some basic function related to trees, insertion and deletion. Now we will look some more function related to trees that are transverse. So transversal is basically means traversals in a binary tree refers to the process of visiting each node in the tree exactly once in some systematic way. So let's say we have some elements in third tree, 143. Transversal simply means you want to visit each and every element node of a tree at once in a systematic manner. Because if we will be doing it in systematic manner, that will be kind of helpful for us so that we don't waste time in visiting the same element again and again. So it it has various ways to do transversal. So we will be going with in order traversal. It's a kind of way to visit each and every node of the tree in special way, that is left, root, right. So we will be doing how, let's say we will be writing our no output of visiting this. So what precedence will we have? Left, root, right. So let's say we are on root 1. What we first have to do? Left. Then we will go left again. We will again perform left, root, right on this one also. Then this again we will go to left. That is this. And again left, root, right on this. Then again we will go down. That is left on this. So what we found? 4. So there is no left than 4. Then else we will perform left root right on this. Then we go to left, that is null. Then we go to root, that is for itself. Then we just set for printed. Then right, there is nothing in right. So we will go back. At 3, we have already performed left. So it's the term of to perform right. So we will just simply print 3 and then right. As there is something in right of 3, so we'll go there and then we will perform left to right. There is no left, and then of course move, then we will perform, right, and 5. Then we will go back, and again from 3 we will go back to 2. In 2 we have already left function. So now it's come to do function. Then this 2 itself, and after that 6. Then as we have performed L left function of 2, then go back to 1. In perspective of 1 we have performed left. That is done. Now it's turned out to this one itself. So next element that will print will be one. Then we will go to right. As we will perform left to right to this, there is something left to it. So we will first go to left. Then again left to right we will click. Then again down to 10. There is nothing, neither left or right on this. Then simply 10 will be printed as 2. Then as we have done with 10, we will go back. There is nothing left. We have done. And now root node, talking about root node, then we went 8, right? There is nothing in right. So go back. We are done with left in this case in perspective of 7. So now it's the time to deal with 7. So we will simply print 7. So in this we are done with left, root also, and we will go to right. That is 9. On 9 also we will again go left and left 7, return to 7, then we will move to right of it. Then we will again perform left 9. So we have something left of it? Yes. We will go to 11. Again left to right on 11. No left, no right. Simply go to that 11. Then we'll go back. We'll go back. Then we are done with left. Next one is so that is 9 itself. So we 9, then in last 12. So this is the way to visit each element root each element of tree at once only. You can see each node is printed at once only. This is the way to visit transversal in binary tree, that is in order transversal. So next way to of transversal is that is pre-ordered transversal. Pre-order means from the row of root left right. That means first of all we deal with our root, then we will go left. Now let's see in this example. So I will be writing out here. So all we will go to input. Let's get input one. Then we go to left. Then I will again two. And what we will do? Print two. Then next. Then we will go left. Then same on this road left right. So what is the road? Three. And then left. So if road is four, we will go back. On three we are done with four. Left question right. We will get right printed. We'll go back. We are done with 2 and left. We will go to right of 2. That is our 6. we will get 6 printed here. Now going back, done we- on done we on two we have done all operations. Root also left, right also, then we will go back. On one we are done with root left, then we will go to right. That is 7. Then again on 7 we will perform what? Root left and right. So what is the root? 7. We will get 7 printed. Now again we will go to left. On left, what we have again we will say root left, right. So what is the root? 8. Now again left 10, root of 10 itself, and because it has neither left side nor right side. Then go back to 8, no other person. Go function left, again go back, both go back to 7. 7 done, that is good. Left done. Now just go to right, that is 9. Again same root, and we'll go to left, left, and then finally 12. So this is another way of visiting each element, each unit of part 3, that is pre-ordered. The last kind of traverse is post-ordered traverse, in which we go to left, then we go to right, and then we simply go to root. So as I have explained two kind of traversal in details, we will just simply, string up the things and writing the output as we have written. So first going to left, then again the same left, right to this, then again left, then the same left. So coming to fourth, we have neither left nor right. So simply that is for itself will get printed. Now go back to three, then in three we are done left. So now go to that is five, coming back three. Now it's some finding the term of three to get printed because we are done left, right. So now it's turn of two. That is three. Then going back to two. In case of two, we are done with that is this whole. Then we will go to right. And on six, we will again left, neither left nor right. So simply go to that is six itself. We will get six printed. Now we'll come back to two. In case of two, we are done with left, we are done with right. The final letter of two, that is two itself. Let's get our two printed. So now we will go to the in case of one, we are done with left, but we are left with right. First of all, we will get our right printed, and then we'll get our one. So coming to this right side, 7, again same, left, again left, this, that is 10. There is neither left nor right of 10. Then finally the root that is 10 itself, we will get 10 printed. Then going up, in case of 8, we are done with left, no right. So root itself that is 8, we will get 8 printed. Then going back to 7, in case of 7, we are done with left, that was this branch. Then we will go to right, that is 9. Again the same concept on 9, left, 11, we will get 11 print. Then go back, then 12, that is right of 9. And then finally the so that's 9. And then as we are done with 9, we will go back to 7. In case of 7, left done, right done. So it's finally the turn of 7. And then after 7, we will go back to 1. Finally, so our root node will get printed because we are done with left side also, right side also. So now finally 1 will get printed. So these were the three kind of transversal in binary trees, and we have also seen how to insert elements in our binary tree, how to delete nodes from binary tree, what kinds of transversal, and the basic information about node, what we call which node we have done there. So now we will just do the coding of all these what we have performed. So let's dive into the code. So let's begin code and perform all the functions that we have just understood in terms of code, how we can suppose write at last we have to generate code. So what we will do, we will first of all create simply a class, name it tree node. Now defining our constructor. Now what will it contain? Self and key. Will this tree node class contain self dot left or none? As of now, it's none. So what the self dot next left means that node will contain the information related to its left side. Now self dot right, that is also none as of now. So it will contain information about its right side. Now self dot value, that is key. So of course the third param thing will be a key itself, that will be in our tree node. Suppose we have discussed earlier that node in linked list contains single linked list contains two parameters in it. First of all its value, then the address of next list. But in tree node it contains value and address of left child and as well as right child. Now we will write a function to insert elements in our tree. We will name insert, will pass row and key in. So in row is none. So what would be meant by root? Root simply meant first have a node, root or binary tree is all root. So if the root is return, we know that is tree. So if there is nothing in root node, so we'll simply add the root node. Now next condition what we will write if root dot left is none. So if the left child is run, if the left child of the root node is none, then we will simply add that root dot add that value to the left child. Insert root. Here we have kind of done and go recursion. We have called insert function insert cell. So yeah, this is the code with light right now. Else else root dot right is none. The node is empty, so we will just root dot right equals to insert root dot right and we will simply pass key. So we just let's say else we'll write again else condition that will contain for random. random dot choice is the pulse inside to left and then after right plus inside walk get right and then left. So here simply none of this is true. So we'll again import random and check whether it's true or false. If true or false, then code will add the value to the ref and source, then else will go to else statement and it's in the right mode. And done. Still to figure out this. Kind of function to just delete any element in node and go and um, return to what if there is nothing. So what to the next listen if what what value equals key. So something in the value root dot value there is something and we will just simply delete that and make it none. Else what statement can do else root dot left is not fun. If there is something in left, we are done with root case, then we will see the left children of root. Delete root dot. Again we have insertion and and the same recursive function is else true for right is not none. So right dot. So now by this function, uh, so by this function we can delete any node from our tree. Next function that we will write, we will be writing to and say, let's say, first of write the loader simply find if there is something into the flow. Some spaces. And then what we will again form function in this. We will yeah, yeah, we will files. Then what we will left. Again the same function. We order also and we pass to for right. This is the very basic function to write the ordered travels. First, what because what we do with the ordered travels, so first we print to, then left, then we write the function of not define not a also just pass to the instrument info zero. Then in order types first we what we used to do is print left mode. So again all the function in order traversal and pass left dot with the root of left input, then then root of value spaces, then again in order transfer root dot right. So the last kind of transfer that is reorder post order traversal kind of traversal. In post order what we used to do is first left then right, and then finally the root. It root again call itself post order traversal root dot left finally then root and which expresses the functions to add insert root delete reorder in order post order traversal. To stand for this example, some root was none and we say please take these one, two, and seven random number 7, 3, 6, 8, 9, 4, 10, 11, but plus 4, 4, 3, and keys was insert key. By this function, we will setting these values what that's what you will do. Have certain values. Let's say rent, so one third next line rent six for pre-order console. We will simply call pre-order transfer function for root. Now rent what next possible or not say that in order sorry rent post order order. So let's say um, no so that we can use all the functions or methods that we have built in your node. So now that's So it has 8, 4, 7 not for that. Except that even after deletion with same options, we will simply copy paste them. So yeah, the order one period mentioned this is you have to pre-order house then in order. So that's all from the code from the trees that I made to understand the complexity. That's all, we need to basically understand about trees basic function, insertion, deletion, and all kind of functions that. Thank you so much.